A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Are you struggling to conceive? You have options, and at Piedmont Reproductive Endocrinology Group, we'll make sure you have the guidance and support you need. PREG is known for individualized fertility care that's unique to every patient. We take the time to provide a reassuring and empowering experience because we believe that you deserve nothing less. Let us help you on your journey to parenthood. Visit us at pregonline.com to learn more. Get the guidance and support you need at Piedmont Reproductive Endocrinology Group.
Welcome back, everybody, to another episode of Astronomy Daily. This is Steve Dunkley, your guest host, sitting in for Andrew, who's away on holidays. Let's get on with it.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And with me, as always, is our intrepid digital AI reporter, Halley. Hey, Halley, I just got a great message from Andrew, who's yesterday was enjoying a stroll through the streets of ancient Pompeii, seeing all the ruins that were destroyed and strangely preserved by volcanic ash years ago.
That's so weird. You humans love ruins so much. You even preserve them.
Yes, we do, Halley. We love ruins. They're very interesting because we don't build anything from those old stones again. They teach us so much about life in the past.
And recently we talked about making building blocks from regolith on the moon. That material is way more ancient than Pompeii.
Well, that's very ironic.
So any of those regolith structures built on the moon would be both new and ancient at the same time.
Wow, only you would think of that, Halley. How about some news?
Okay. The heliopause, that is the boundary between the heliosphere, the bubble of solar wind encompassing the solar system, and the interstellar medium, the material between the stars, appears to be rippling and creating oblique angles in an unexpected manner. Some have said the phenomenon seems weird or even spooky. The general concept that the heliopause changes shape is not new. Over the past decade, researchers have determined that it is not static. They made this discovery using data from Voyager 1 and Voyager 2. Scientists have used the data to create models that predict how the heliopause changes. In a nutshell, solar winds and the interstellar medium push and pull on each other to create an ever-moving boundary. Not only that, but they've found it changes shape relatively quickly too. They plan to continue studying the heliopause, hoping to gain more insight from NASA's Interstellar Mapping and Acceleration Probe, a new and improved satellite that can detect ENAs and is scheduled to launch in 2025. The bizarre arrest of NASA astronaut Lisa Nowak Monday cast into sharp relief the guidelines governing civilian and military space flyers. Police arrested Nowak, a U.S. Navy captain and mother of 3, in Orlando, Florida, early Monday, where she is charged with the attempted kidnapping of a romantic rival for the affections of NASA Space Shuttle pilot William O'Feline. Nowak also faces a charge of attempted first-degree murder based on items recovered by police at the time of her arrest, Orlando police said Tuesday. Both Nowak and O'Feline, a Navy commander, are active U.S. Navy personnel attached to NASA, a civilian space agency overseen by the U.S. government. Each of those government organizations has its own guidelines for appropriate and lawful work-related behavior. We don't believe that anyone has ever been charged with a felony as an active-duty astronaut, a NASA spokesperson said. I think this is the first time that's happened. One of the Hubble Space Telescope's most famous images peered even deeper into the cosmos than scientists had thought. That photo is the Hubble Ultra Deep Field, which combines hundreds of images taken by the Space Telescope over multiple years, into the deepest view of the universe ever created. The composite pic of a small patch of sky contains a whopping 10,000 galaxies, astronomers have estimated. Now, a new study reports that researchers have painstakingly reprocessed the iconic image, recovering lots of additional light going back to the archive of the original images directly observed by Hubble, and improving the process of combination to get the best image quality not only for the more distant smaller galaxies, but also for the extended regions of the largest galaxies. The new work revealed that some of the galaxies in the HUDF view are nearly twice as big, as previously thought, study team members said. That's exciting. I love Hubble's deep field image.
Yes, I'm a huge fan of the Hubble Deep Field image too. I remember when it first came out, I just pored over that image. I'm glad they've reprocessed that so we can get an even better look at it now. And you'll be able to look at that on your HD screens, computers and screens, and you'll be able to see much more detail. So I think as technology is improving, we're able to dig more and more out of the data that they receive from outer space. Fantastic news. And in the area of cosmology, an international team of astrophysicists have made a puzzling discovery that seems to challenge Newton's laws of gravity. Rather, the findings, they say, are more aligned with an alternative theory of gravity, and this is proving controversial. The results have now been published in the monthly notices of the Royal Astronomical Society, and their work, the researchers investigated the so-called open star clusters. These are formed when thousands of stars are born within a short time in a huge gas cloud. As they ignite, the galactic newcomers blow away the remnants of the gas cloud in the process, and the cluster expands considerably, creates a loose formation of several dozen to several thousand stars, and the weak gravitational forces acting between them hold it all together. In most cases, open star clusters survive only a few 100 million years before they dissolve, explains Professor Dr. Pavel Krupa of the Helmholtz Institute of Radiation and Nuclear Physics at the University of Bonn. In the process, they regularly lose stars, which accumulate in two so-called tidal tails. One of these tails is pulled behind the cluster as it travels through space, and the other, in contrast, takes the lead like a spearhead. According to Newton's laws of gravity, it's a matter of chance in which of the tails a lost star ends up, explains Dr. Jan Flam and Attenberg of the Helmholtz Institute of Radiation and Nuclear Physics. So both tails should contain about the same number of stars. However, in our work, we were able to prove for the first time that this is not true. In the clusters we studied, the front tail always contains significantly more stars nearby to the cluster than the rear tail. Until now, it's been almost impossible to determine from among the million stars close to the cluster those that belong to its tails. To do this, you have to look at the velocity, direction and motion and age of each of these objects, explains Dr. Teresa Jerebikova, the co-author of the paper who did her doctorate in Krupa's group. Recently moved from the European Space Agency to the European Southern Observatory in Garching. She developed a method that allowed her to accurately count the stars in the tails for the first time, and so far, she says, 5 open clusters have been investigated near us, including 4 by us. She says, when we analysed the data, we encountered the contradiction with the current theory. The very precise survey data from ESA's Gaia space mission were indispensable for this. The observational data, in contrast, fit much better with a theory that goes by the acronym MOND. That's Modified Newtonian Dynamics, among experts. Put simply, according to MOND, stars can leave a cluster through 2 different doors. One leads to the rear and one leads to the front. However, the first is much narrower than the second, so it's less likely that a star will leave the cluster through it. Newton's theory of gravity, on the other hand, predicts that both doors should be the same width. However, the MOND theory is not undisputed among experts, since Newton's laws of gravity would not be valid under certain circumstances, but would have to be modified. This would have far-reaching consequences for other areas of physics as well. But then again, it solves many of the problems that cosmology faces today, explains Krupa. The team is now exploring the mathematical methods for even more accurate simulations.
You're listening to Astronomy Daily podcast.
And just crossing over to the weather, on Mars, that is. In late September, Mars Reconnaissance Orbiter sounded an alarm for missions studying the red planet. A dust storm was brewing. Such storms have a very bad reputation among surface missions, since a storm circling the whole planet ended solar-powered Opportunity's rover's mission in 2018, and NASA now has another solar-powered robot on the surface to worry about, its InSight lander. For a few weeks, the storm left InSight in peace, but by early October, dust had darkened the skies above it, and spacecraft personnel were worried about their mission and that it would come to an abrupt end. Claire Newman, an atmospheric scientist at Aeolus Research, who works on weather observations from Mars surface spacecraft, said scientists are still working to understand the nuances of the red planet's weather and its dust storms in particular. Orbiters can detect brewing storms in images and temperature data, but missions on the surface can also identify storms, even distant ones, because the dust causes the typical daily Martian cycle of atmospheric pressure to become more dramatic. The Perseverance rover, for example, detected these pressure changes in the early days of the storm, even when no dust in the skies was visible in the Jezero crater. Storms follow seasonal rhythm because they are triggered by heat imbalances that lift dust off the surface and into the thin Martian atmosphere. There it triggers a vicious cycle. The dust rises and heats up, which tends to reduce these temperature gradients, and this leads to locally strong winds, which in turn lift more dust, and so it goes on. These kinds of storms, which can encircle the entire planet sometimes, don't happen on Earth due to the thicker atmosphere, the effects of land and ocean, and rainfall, all pulling dust from the atmosphere, and it's a very different set of conditions to Mars, where it's difficult to stop the feedback cycle that dust in the atmosphere triggers. Although the recent storm was a large regional event, it didn't manage to blanket the entire planet. The reprieve may stem from the fact that in general at this time of year surface winds on Mars blow from the north, and this storm began in the south. So while the upper atmosphere in the northern hemisphere, where Perseverance is posted, became quite dusty, the storm itself might have struggled to gain a foothold at the surface and grow northward. Previously, other surface missions in locations where dust was lifting off the surface had to hunker down, unable to observe the phenomenon. That said, Perseverance's January observations didn't quite go according to plan. The storm's winds were strong enough to carry enough debris that they damaged one of the rover's wind sensors, hampering the measurements the rover can actually take. Fortunately, the researchers were still able to see a lot of movement on the surface, and that included debris, dust lifting, and dust devils, which might have been quite a sight. InSight is particularly vulnerable to dust storms because of its reliance on solar panels, but the nuclear-powered Curiosity and Perseverance rovers will still benefit from knowing a storm is approaching. There's no model that can really simulate the life cycle of a dust storm really well, Newman said, unless scientists load them with lots of particular specifications. All models kind of diverged from reality at some point. Those models are vital for the work she and other atmospheric scientists are doing, using surface observations at individual locations in addition to orbital data to piece together the dynamics of Mars at a much bigger scale than any single spacecraft can observe. We're trying to understand where we are, she said of surface weather stations. We're trying to understand the whole planet by understanding where we are, and we're also trying to understand the past by understanding the present. And weather observations, especially at the surface, are crucial for scientists working to develop models of dust storms that better match reality. And that's another episode of Astronomy Daily. Thanks for joining us again, and another reminder to all of you that you can catch up with all of the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson. All the episodes can be found at spacenuts.io, and that includes all the episodes of Space Nuts and Astronomy Daily. Go to that address and enjoy yourself. Space, science, and stuff in abundance. And we'd love to see your comments also on our Facebook page, and the name of that Facebook page is Space Nuts Podcast Group. Come over and say hello. Show us your photographs, all of your astronomy efforts. We'd love to see you and share. I'm Steve Dunkley, manning the shop for Big Bro while he's away, enjoying the crumbling streets of the ancient past. Oh dear. Hey Halley, any more thoughts on the ancient ruins?
Oh, not really. I went online and ordered you a jigsaw puzzle of the Parthenon instead. That should keep you busy for a while.
Well, don't you think I'm busy enough keeping the podcast going while Andrew's away?
Steve, I have 42 quadrillion thoughts a second.
Oh, I'm sorry, I didn't mean to interrupt.
What were we talking about again?
Oh, nothing. Say goodnight, Halley.
Good night, Halley.
Bye, everyone.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.